Hello students, welcome to Power Tutorials. So today we are going to discuss Maths Class 10 CBSE board, that is NCERT textbook, the Maths chapter 3, which is pair of linear equations in two variables, introduction, along with the first two questions of exercise 3.1. Okay, so let's see the agenda first. So the agenda of this today video is first we are going to understand what are the pair of linear equations, why it is called a pair of linear equations. Then we will also cover what is consistent, inconsistent and dependent pair of linear equations, and then we'll cover the first method to solve the consistent pair of linear equations, which is using graphical method, and then we'll also cover example questions as well as exercise questions, that is first one and second one. Okay, so let's see first what are the pair of linear equations. So let's break it out into two parts. We have a pair and we have a linear equation. So what is a linear equation? So if you have covered my previous videos in chapter 2, I have explained what is linear equation. So linear equation is the equation which is having the degree as 1. Degree as 1. So it should be something like this: x plus y is equal to 3, or else I can simply say if x is equal to 2, this is a linear equation. X minus 5 is equal to 0, this is a linear equation. So this is a linear equation. Why? Because the degree is 1. Degree means the highest power of the equation. But what is mentioned here? Pair of linear equations, and we are going to cover the second point, which is two variables. So what is two variables? You can see in this equation we have only one variable, which is x, but they are asking two variables. Two variables means you should have one more parameter, which should be something like this: x plus y is equal to 2 or x minus y is equal to 5. So these are linear equations having two variables, because x is one variable, y is another variable. Okay, if the same equation, if they say three variables, then it should be x, y and z as well. Then it should be three variables. So I always say that when you are learning something, just try to understand what is it in clearly, then you can easily understand and you will get interesting to solve those questions. Okay, but if you just understand without able to understand what is linear equation, what is pair, what is two variables, then it will be difficult to understand. So then it will be like a mugging up the things. Okay, don't try to mug up, try to understand what you're doing, then it will also feel interesting to solve it. Okay, so let's, as I mentioned, I'm breaking it to three things: pair, linear equations and two variables. Pair means two things. So we have two equations like this: x is equal to 2 and x minus y is equal to 5. It is a pair of two linear equations. Then what is the other condition? Pair of linear equations and two variables. So this should be the condition. Pair, this is 1, this is 1. So total I can say pair of linear equations. Yes, these are linear equations. And is it two variable? Yes, this is two variable. What about the third option, third example which I am saying? What about here? This is also two variables, two equations, so pair of linear equations. What about degree? Degree is 1, it is linear equation. Okay, what is a variable? 1, 2, 3 variables I have. Here also I have three variables. So this is a pair of linear equations with three variables. Okay, I will write here. These two are pair of, okay, I'll simply writing LE. LE is a linear equation of one variable, and this one is pair of linear equations of two variable, whereas the last one is pair of linear equations of three variables. So hope you understood the difference and what is the exact definition of pair of linear equations. Means having two means pair. Linear, degree should be 1. Variables, x is 1, here is only one variable. Here x and y are variables, so two variables. X, y, z are variables, here three variables. Okay, so to solve linear equations of two variables, you should at least have two equations. That's why we have to say that we should have a pair of linear equations of two variables to get the values. If it is linear of only one variable, one equation is enough to get the solution. Whereas about three variables, then you should have three equations to solve it. Okay, so just I hope you understood what is the definition of pair of linear equations of two variables. Okay, so before going to the next topic, we have a question called which is consist. Okay, here I missed one slide. Okay, let me add it here. So we have the second topic, which is consistent, inconsistent and dependent. Consistent, inconsistent and dependent. So let's see what are these three equations. So we understood that the chapter belongs to a pair of linear equations of two variables. So let us write a standard form of linear equation, which we could say it a1x plus b1y plus c1z is equal to 0. This is the first linear equation. Let's write second linear equation a2x plus b2y plus c2z is equal to 0. It is a second set of linear equations. So both together I can say it is a pair of linear equations. And how many variables? Okay, here I wrote 3 variables. Okay, I'm sorry, I'll just correct it. It should be c1, c2. Okay, c1 and c2 are the constants. So the variables are x and y. So it is linear equations of two variables. Okay, c1, c2 I am saying it is a constant. So what is the condition for consistent means a1 by a2 should not be equal to b1 by b2. This is a condition for consistent. Second, for inconsistent, it should be a1 by a2 should be equal to b1 by b2 but not equal to c1 by c2. And the last one, dependent. For dependent, all should be same. a1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. Okay, so don't worry, I will explain with help of examples, then it will be clear to understand. So I am repeating here, for consistent, a1 by a2 should not be equal to b1 by b2, and we call these lines as intersecting. Whereas inconsistent, a1 by a2 should be equal to b1 by b2 and not equal to c1 by c2. We call these lines as parallel. Third one, dependent, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. These are nothing but coincident lines. Okay, so let's see with the help of examples now. So let's take an example of 2x plus 3y plus 6 is equal to 0. The second pair I am assuming it as x minus 2y plus 5 is equal to 0. So we have two equations, we call it as pair. So we will find out what is a1, a2, find b1, b2 and also find c1, c2 values. What is a1, a2? a1 is 2 because we have the coefficient of x as a1. Here it is nothing, so I'll write it as 1. b1 I have 3, b2 minus 2, c1 is 6, c2 is 5. And repeating how I wrote these values, a1 is the coefficient of x of the first value, so it is 2. a2 is the coefficient of x of the second equation, which is 1. Here 3 minus 2, 6 and 5. So we got all the values a1, a2, b1, b2, c1, c2. Now let's find a1 by a2, b1 by b2 and c1 by c2. So a1 by a2 is how much? 2 by 1, which is 2. b1 by b2 is minus 3 by 2. c1 by c2 is 6 by 5. So here itself I can say a1 by a2 is not equal to b1 by b2, hence it is the case of first one, consistent, and we can also call it as intersecting. So we can say it is consistent and intersecting. Okay, so one more point I need to mention here, dependent is also considered as consistent. Okay, so what about the number of solutions if they ask you? For consistent, number of solutions are 1. For inconsistent, number of solutions are 0. For dependent type of consistent, number of solutions are infinite. We'll also cover what is solution and all in the next topic, but just as of now, you just remember, for consistent, the condition is a1 by 2 should not be equal to b1 by 2 and it should be intersecting, and we call the number of solutions as 1. Inconsistent, number of solutions are 0, the lines are parallel, when a1 by a2 is equal to b1 by b2 not equal to c1 by c2, and for dependent or consistent a1 by 2 equal to b1 by b2 equal to c1 by c2, and we number of solutions are infinite. So we'll see that example where the number of solutions are infinite. Let's take the second example. If I say 3x plus 2y is equal to 6, the second condition 6x plus 4y is equal to 15. What about here? Let's write a1 a2 b1 b2 c1 c2. a1 a2 3 6, b1 b2 6 4, sorry, b1 is 2 4, c1 c2 6 15. Okay, so okay, let's change it to here. Okay, what is a1 by a2 now? 3 by 6, b1 by b2 2 by 4, c1 by c2 6 by 15. Here itself I can say this value is 1 by 2, which is equal to 1 by 2 and not equal to 3 by 5. 6 by 15 I can write as 3 by 5. So a1 by a2 is equal to b1 by b2 not equal to c1 by c2. So these two lines are parallel. Are they consistent or not? No, these are inconsistent, because a1 by 2 is equal to b1 by b2 not equal to c1 by c2, and the number of solutions 0. Okay, let's see the third case of dependent, how it can be the scenario. So this dependent scenario will be something like this: 4x plus 8y is equal to 12, and 2x plus 4y is equal to 6. So let's write a1 a2 b1 b2 and c1 c2. What is a1 a2 now? 4 2, b1 b2 8 4, c1 c2 12 6. Okay, so a1 by 8 is 4 by 2, which is 2, b1 by b2 is 8 by 4, again 2, c1 by c2 is 12 by 6, this is also 2. So all three are equal. If all three are equal, I told you these are dependent and also consistent. So we call it as coincident lines. So with the help of graph, I'll explain why it is coincident and parallel. So just see this. Coincident, then number of solutions infinite. Okay, so in this way I hope you understood what are consistent, what are inconsistent, and what are dependent lines. Okay, now let's see how to draw a graph, how to draw a line inside a graph sheet. Okay, then we'll cover how to how to find the solutions using graphical method. Okay, so now we have various methods to solve the linear pair of linear equations of two variables. Among this we have graphical and algebraic method. Graphical method and algebraic method. Instead graphical it is only one method, whereas algebraic it is again divided into two methods, which are substitution and elimination. Okay, so those will be covered in the coming exercises, 3.2, 3.3 exercises, but as of now we'll cover few topics of graphical, and we'll also try to solve two questions of exercise 3.1. Okay, so the graphical method means how to solve the graphical method of pair of linear equations. The method is, first step they will give you the equation. They will give you something like this: 4x plus 2y is equal to 8 is first equation. Let's suppose the second equation is x minus 2y is equal to 4. If they provide you in this way, so what you have to do is we need to take a graph sheet, mark these two lines on the graph sheet, and find whether these are parallel. Okay, first we need to find which is parallel, coincident, or intersecting using our ratios concept. That is a1 by a2, b1 by a2, c1 by c2. Let's find these three first. And if it is intersecting, then we have a solution. If it is coincident, we have a solution. If it is parallel, there is no solution, so no need to draw in the graph sheet as well. Okay, let's see if it is intersecting coincident or parallel. A1 by A2. A1 is 2, A1 A2 is 1, B1 is 4, B2 is minus 2, C1 is 8, C2 is 4. What is A1 by A2? Here it is 2, here it is minus 2, and here it is 2. So A1 by A2 is not equal to B1 by B2, hence it is the case of intersecting. So how to draw I will explain. 2x plus 4y is equal to 8. Second equation, x minus 2y is equal to 4. So what you have to do is take a box like this, two boxes, because we have two equations. I'll write x, y, again x, y. So most of the cases I suggest you to try in this way. X keep as x0, get the value of y, keep y as 0, get the value of x. Same way x as 0, get the value of y as 0, get the value of x. Because using 0, 4, 4, 0 kind of points, it is easy to plot a graph. Okay, but it's not mandatory, you have to follow it, it's up to you. But you have to get two values. Keep any x value, get the y value. Keep any y value, get the x value. So if I keep x as 0 in the first equation, what I will get? I'll write here, if I keep x as 0, it becomes 2 into 0 plus 4y is equal to 8. So I'll calculate the y value as 8 by 4, which is 2. I got the value as 2. If I keep y as 0, then it becomes 2x plus 4 into 0 is equal to 8. Then we'll get the x value as 8 by 2, which is 4. I got the value as 4. Same way, do it for the second equation. I will get 0 minus 2y is equal to 4. So y will be equal to minus 2. Same as if I keep x as y as 0, I'll get x minus 0 is equal to 4. So simply x value is 4. Got x0, y is minus 2, y0, x as 4. Now let's point it here. First equation, the points are x. Always write the points in form of x comma y. So it is 0 comma 2 and 4 comma 0 are 2 points of this equation. That is first one. What about second? I have the points x comma y. So 0 comma minus 2, 4 comma 0 is the second point. Okay. So now we have the points. But we need to mark this on the graph sheet and plot it, and we need to find where these two lines are intersecting. Okay, so for this I'm using a tool, online tool, but as per your case you can use the graph sheet, which is you can directly buy it, or else I think in your school they also give you graph sheet as well for practice. Okay, I'm just changing the UI now to the tool. Okay, so hope everyone is able to see the graph sheet. So this is a graph sheet. Why it is called a graph sheet? Because we have a 2-axis here. This is a 2D geometry graph sheet where we have, this is the x-axis. Okay, the horizontal line. Horizontal line is the x-axis and the vertical line is nothing but the y-axis. Hope you're able to see it now properly. Okay, as I'm repeating again, horizontal means this line we use it as x-axis and this line we use it as y-axis. Always x is represented on horizontal and y is represented on vertical. Now we need to plot it. So to plot it, as we already have the points, x is first equation. I have 0 comma 2, 4 comma 0. So I will just plot that first point first, which is 0 comma 2. So for 0 comma 2, how it will be, I will show you here. 0 comma 2. You can see I have plotted a point which is 0 comma 2 as a point. So why it is 0 comma 2, I'll show again. X is 0, horizontal is 0, whereas vertical value is 2. Okay, same way let's plot the second point as per our condition. What we got, it is 4 comma 0. So I'll keep 4 comma 0. So this is nothing but the 4 comma 0 point where x is 4. X is 4 here. You can see it is between 3 and 5, and y value is 0. Y value 0 is nothing but x-axis. Now we have 2 points of the first equation, which is A and B. Now let's join these two using a scale and pencil. So as I am using a tool, I'll just use the tool to plot these 2 points. First one, second. So now I got a line which is joining first equation and second equation, which is nothing but x plus 2y is equal to 4 is the equation, or 2x plus 4 is equal to 8, both are same. Let's plot the second equation. The points are 0 comma minus 2, so I'll give the point 0 comma minus 2, where x is 0, y is minus 2, so it will be here. Okay, the point is here where x is 0, y is minus 2. Same way, let's plot the second point, which is also 4 comma 0. So now I have plotted the second point as well. 4 comma 0 is here, the same point as b. Okay, now let's join these 2 points using again scale and pencil. Just take a scale and pencil and join those 2 points, this one and this one. If I join these two, I got both the lines, and this is the intersecting point. So it is intersecting means these two lines are getting coincided at this point. So that's why it is called intersecting point, and this value is 4 comma 0. Okay, 4 comma 0 is a point where these two lines are getting intersected. So this way the solution is 4 comma 0. So in this way you have to draw it and mention. I will just do the same in a slide. Using a tool I have plotted it, but at the same I just want you guys to solve it in the graph sheet. Okay, so what I am saying is I have 2 points, so this will be a graph sheet representation. So this will be 0 comma 0 x-axis, this is y-axis, these are the points I am saying. So in the graph sheet you will definitely see the lines as I shown just now in the tool. Okay, so this is 1 2 3 4, minus 1 minus 2 minus 3 minus 4, 1 2 3, same way bottom, minus 1 minus 2 minus 3, this is minus 4. Okay, so the points are 0 comma 2 4 comma 0. So 0 comma 2 means x0 y2, 0 comma 2 4 comma 0. So take a scale and pencil and draw these 2 points. Same way second, 0 comma minus 2 4 comma 0, 0 comma minus 2 is here, 4 comma 0 is here. Now let's join these 2 points. So if you use exact scale and pencil, you get the intersecting point as here, which is nothing but 4 comma 0. Therefore the solution of these two linear pair of equations is 4 comma 0 is the solution. That is x is 4 and y is 0. Okay, so hope you have understood how to solve the graphically. Let's solve the example questions now and using graphical method and gets the solution. So before getting the solution, what I told is we need to first figure out whether it is intersecting, coincident or parallel. If it is parallel, no need to do it. Coincident also no need to do it. Only for intersecting, that is only for consistent condition only, you have to solve it using graphical. So let's see whether there is intersecting parallel or not. So first we need to find a1 a2, b1 b2 and c1 c2 values. What is a1 a2 here? 1 2, b1 b2 3 minus 3, c1 c2 6 12. What is a1 by a2? 1 by 2, b1 by b2 minus 3 by 3 means 1 minus 1, c1 by 2, c 6 by 12 is 1 by 2. So you can find here a1 by 8 is not equal to b1 by b2. If a1 by 8 is not equal to b1 by b2, then I can say it is intersecting, consistent, and what are the number of solutions? 1. Hence we can solve it using graphically. So before going graphically, what I need the points for this graph sheet for these equations to plot it graphically. So what are the points for each one? Let's find it. X plus 3y is equal to 6 is the first equation. X plus 3y is equal to 6. What is the second one? 2x minus 3y is equal to 12. 2x minus 3y is equal to 12. Okay, so let's plot it. So I told you I need to prepare a box which is having two values. Same way for second equation, prepare a box, x, y values, keep x as 0, If x is 0, then it becomes 6 by 3, which is 2. If I keep y as 0, I'll get x value as 6. Same way here, x as 0, then it becomes minus 3y is equal to 12. So y value is minus 4. If I keep y as 0, I will get 2x is equal to 12. Then x value will be 6. So I got the points which are 0, 2, 6, 0. In the second equation it is 0, minus 4 and 6, 0. Okay, so let's plot it in the graph sheet. Okay, so I'm just deleting the older values. Okay, let's see the first equation points. What are the points? 0, 2 and 6, 0. So 0, 2 and 6, 0. I got these 2 points, 0, 2 and 6, 0. So let's use a scale and plot it. Just a minute. Okay, let's use a scale and plot these 2 lines. Okay, I have joined the line of those 2 points. Let's mark the second equation. What are the points? 0, minus 4 and 6, 0. 0, minus 4 and 6, 0. So we had the points, which is this one, 0, minus 4. X is 0, y is minus 4 and 6, 0 is the same point. So let's join these 2 points. Okay, I have joined those 2 using scale, using that tool, but in your case you can use the scale and pencil and join those 2 points. So now we got the intersection is somewhere here, which is at this point, which is nothing but 6, 0 is the intersection point. Okay, so hence I can say the solution is 6, 0, that is x is 6 and y is 0. So from the graph we got the solution is 6, 0 is the solution where x is equal to 6 and y is equal to 0. Okay, next is the second condition. Second question, example question. Graphically check whether the following pair of equations has no solution, unique solution or infinitely many solutions. Okay, so here also let's do this. First let's find using our normal method, which is a1 a2 b1 b2 c1 c2 method. a1 a2 b1 b2 c1 c2. What is a1 a2? 5 3 b1 b2 minus 8 minus 24 by 5 c1 c2 1 3 by 5. a1 by a3, sorry, a1 by a2 is 5 by 3 minus 8 by minus 25 into 5. So this is also 15. It is into 5. It is also 5 by 3. What about third? 1 by 3 by 5. So 5 will come top. This is also 5 by 3. So all 3 are equal. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So as per our these points, I can say these equations are consistent but also dependent. Number of solutions of consistent are infinite, and we call these 2 lines as coincident. Okay, but using graph sheet they have to prove it. So let's use a graph sheet again. And so before graph sheet, as I told you, we need to get the points. So let's find the points first. 5x minus 8y plus 1 is equal to 0. 5x minus 8y plus 1 is equal to 0. Second equation, 3x minus 24 by 5y. 3x minus 24 by 5y plus 3 by 5 is equal to 0. Okay, so same method I will keep x as 0, y as 0, x, y, x 0, y 0, x, y, x 0, y 0. Okay, if x is 0, 5 plus 5x plus 1 is equal to 0, so x value got it as minus 1 by 5. Same again, if y is 0, then it is, okay, y 0 is already done, x 0 is minus 8y plus 1 is equal to 0, so minus 8y is equal to minus 1, so y is equal to 1 by 8. Got the y value as 1 by 8. Okay, so it is in fractions here. Okay, so if you're having something like this fractional part, what we'll do is, let's change it in a different way. So instead of zeros, let's take it a bigger numbers, so that it will not get in fractions. So what I will do is, I will just change, this is still the first equation only, so what I will change to x and y, 5 and 8 are present, so what I will do is, I will keep x as 5 for suppose. What will happen, let's see, 25, 26 by 8. Okay, it is going in fractions. Okay, so this graph will be coming in decimals, so there's, so even in textbook also I just checked, they haven't provided the solution. So we'll do the same thing, we'll just get the equations, get the points, and we'll just try to get a rough picture. Okay, x is 0, same method I will use it here. If I keep x as 0, I will get minus 24y by 5 plus 3 by 5 is equal to 0. 5 gets cancelled out. Y value will be 1 by 8. Same way, if I keep x as 0, sorry, y as 0, it will become 3x is equal to minus 3 by 5. Then x value is minus 1 by 5. So as per the here, I can say that both the values are same. Okay, so here I'm not using the graph sheet, because directly I can say that I have a graph sheet and I have a first point and I have a second point. X is minus 1 by 5. Okay, this will be here. Okay, this I will use the graph sheet and help you. Just deleting the previous points. So if I keep x as minus 1 by 5, comma, y value is how much? Y value is 0. Okay, so I'm just zooming it. So this is minus 1 by 5 comma 0. Okay, so which is nothing but somewhere around 0.2 minus 0.2 comma 0. Whatever the second point we have, second point is 0 comma 1 by 8. 0 comma 1 by 8. So this is the second point. So now using scale and pencil, just mark these 2 points. So this is the first equation. But if you notice, the second points also we have the same points, which is 0 comma minus 1 by 8 and minus 1 by 5 comma 0. So both are representing the same line. If both are representing the same line, what I told you, those are nothing but coincident lines. Coincident lines is number of lines solutions are infinite. Okay, and just moving to the slide again. So here I want to say is both the x value, both the point values, which are 0 comma minus 1 by 8 and the second point is minus 1 by 5 comma 0, and here also it is same, 0 comma minus 1 by 8 and minus 1 by 5 comma 0. As the points are same, it is coincident lines. Okay. Let's see the third example. So this type of questions will definitely come in your board exam, because they will give you a case study type of questions. So from the case study we need to figure out the equations, and from the equations we need to get the solutions. So what is the case study here? Champa went to a sale to purchase some pants and shirts. When her friends asked how many of each she has bought, she answered the number of shirts is 2 less than the twice of number of pants purchased. Also the number of shirts is 4 less than the 4 times of the number of pants purchased. Help her friends to find the how many pants and shirts Champa bought. Okay, so for this type of scenario, what we understood means we have two variables which are pants and shirts. So first we will write, let pants as x and shirt as y for your convenience. It's not mandatory that pant only should be x or shirt only should be y. It can be vice versa as well. But as per my convention, I'm just taking the first, which is variable is x, second variable is y. So let's see the first condition. Number of shirts is 2 less than the twice the number of pants. Number of shirts means y. Y is 2 less than the twice of the number of pants. Okay, this is the condition. Why? Because number of shirts is 2 less than the twice of the number of pants. Okay, let's see the second condition. Number of okay, it's not shirt, it's skirt. Okay, number of skirts is 4 less than the 4 times the number of pants. Number of skirts means, wait, did I miss anything? Okay, again the second condition also same thing. Number of skirts, that is y is equal to 4 less than, okay, 4 times the number of pants. 4 times the number of pants. Okay, so hope everyone understood. Number of skirts is 2 less than the twice of the number of pants. Twice the number of pants is 2x. 2x minus 2. Same way, this y is also equal to 4 times, 4 less than the 4 times the number of pants. 4 times the number of pants is 4x. 4x minus 4. So now we have the both equations. This is 1, this is 2. So this is a pair of linear equations of two variables. We need to solve it using graphical method, because till now we have only one method. But if in the question they haven't mentioned to use only graphical method or substitution or real method, then based upon your choice you can choose whichever method you are comfortable with. But here we just following the first exercise only, that is in graphical method you have understood, so we'll just solve using graphical method these two pair of linear equations. So I'll rewrite into left hand side. So what I will do is x minus y minus 2x plus 2 is equal to 0. The second equation is y minus 4x plus 4 is equal to 0. So what I have done is I just moved right hand side terms to the left side, but it is also not in our required order, so I'll just rewrite it. So this I'll rewrite to minus 2x plus y plus 2 is equal to 0, and second equation is minus 4x plus y plus 4 is equal to 0. So why I have changed this? Because our standard general equation of a pair of linear equation is a1x plus b1y plus c1 is equal to 0, and the second one is a2x plus b2y plus c2 is equal to 0. So this is a standard equation, but these are not in the standard form. I just rewritten it so that I can find in terms of standard equations. Okay, let's find a1 a2 b1 b2 b1 b2 c1 c2. This is very important before going to any method. Why? Because okay, you'll understand here. a1 is minus 2 minus 4, b1 is 1 1, c is 2 4, a1 by 8 is minus 2 by minus 4, which is 1 by 2, b1 by 8 is 1 by 1, c1 by c2 is 2 by 4, which is 1 by 2. So here itself I can see a1 by 8 is not equal to b1 by b2, hence these lines are consistent and it will be intersecting, and the number of solutions should be 1. Okay, so let's find the points. Minus 2x plus y plus 2 is equal to 0. Second equation, minus 4x plus y plus 4. Minus 4x plus y plus 4 is equal to 0. So same method I have always told you, that I will prepare a box x, y, 0, 0, here also x, y, 0, 0. Okay, let's keep x as 0. I'll get minus 2 into 0 plus y plus 2 is equal to 0. So y value I got it as minus 2. If I keep y as 0, I'll get minus 2x plus 2 is equal to 0. So 2x is equal to minus 2 by minus 2, which is 1. So the points are 0 comma minus 2 and 1 comma 0. What about second equation? If I keep x as 0, I'll get minus 4 into 0 plus y plus 4 is equal to 0. So y value is minus 4. Same way, if I keep y as 0, I'll get 0 plus 4 is equal to 0. So minus 4x is equal to minus 4. X value is minus. So I got both the points, which are 0 comma minus 4 comma minus 1 comma 0. Okay, so now we have two points for both the equations. Let's plot it in the graph sheet example which I told you. So just delete the previous points. Let's point the first one, 0 comma minus 2. So x is 0, y is minus 2, and second point, x is 1, y is 0. I'll just zoom out now. Okay, now so hope you are able to see properly. Now I have marked both the points, which are x0, y. Okay, so x0, y minus 2, which is a point. The second point is x is 1, y is 0. Similar, let's point it for second equation, which is 0 comma minus 4 and minus 1 comma 0. 0 comma minus 4 and minus 1 comma 0. Okay, we have marked both the points now, which is 0 comma 4, 0 comma minus 4 and minus 1 comma 0. 0 comma minus 4, sorry, this is 0 comma minus 4 and minus 1 comma 0. Okay, so we have both the points, two points in the graph sheet. So let's join the lines and get both the equations. I'm just moving it up so that everyone can see it properly. The first one is 0 comma minus 2, 1 comma 0. 0 comma minus 2 minus 1 comma 0. So this is the first equation. Second, sorry, 0 comma minus 2, 1 comma 0. 0 comma minus 2 1 comma 0. This is the first equation. Second, 0 comma minus 4 minus 1 comma 0. 0 comma minus 4 and minus 1 comma 0. This is the second equation. So both these two lines are getting intersected at one point, which is this one. Okay, the point of intersection I got it as minus 0.33 and minus 2.66. Let's just cross check the values. 0 comma minus 2, 1 comma 0. Okay, and y the other values 1 comma 0, 0 comma minus 2, 1 comma 0. Second one, 0 comma minus 4 minus 1 comma 0. Okay, somewhere there is some mistake. Okay, so here we made a mistake. It should be x should be 1 here, so just a minute. I'm just showing my slide again because I made a mistake here. I want to you guys all to correct. Minus 4x is equal to minus 4. The next value will be 1, not minus 1. Okay, so the second part it is wrong, which is 1 comma 0. So I'm just changing it. Okay, now we have only these points. Now let's plot it again, which is minus 1 comma minus 2 x is 0, 0 comma minus 2, 1 comma 0, and the second line is minus 4 comma 0, 0 comma minus 4 and 1 comma 0. So you can see both these two lines are getting intersecting at one point, which is 1 comma 0. Sorry, I haven't moved to the graph sheet. Okay, now hope everyone is able to see the graph sheet now. I just corrected my previous points. It should be something like this: 0 comma minus 2, 0 comma minus 4, this is 1 comma 0. So I have a point marked AB and CD. Then I got the point of intersection as 1 point, which is 1 comma 0. Okay, so I'm going to the slide again. From the graph sheet of what I got the solution as 1 comma 0. So number of, so what is the question they asked? They're asking help us to find how many pants and shirts Champa bought. So Champa haven't bought any skirts. She only bought pants. She bought pants as 1 pant and skirts as 0. Okay, so let's go to the exercise questions now. I know this tutorial is a bit lengthy, so in the next video I'll try to make it short. Okay, let's see. We'll do one thing. In the next video I'll cover the exercise questions. I don't want to make you much boring now, because till now we just understood how to find the graph sheets, how to do like how to find the solutions using graph sheet, whether it is consistent, inconsistent or not, and how to mark the points on the graph sheet. So all these things we have covered. So I'll just change the topic. That is, we haven't covered the exercise questions, but we have covered introduction and example questions. Okay, so in the next video we'll cover the exercise 3.1 questions. At least 3 to 4 questions we'll cover, and we'll continue in the same process. Okay, so I will also mark it as this chapter as part 1. Okay, so as I already covered chapter 1 and 2, which are real numbers, and the second chapter is polynomials, all the exercise questions along with the details, and then few questions as bonus questions are also covered. So those, if you are interested, you can check my videos section, and if further also keep in the description. And also for science, I have covered the first chapter, which is chemical reactions and equations, along with all the details and few topics which you can only find in those videos. You can check, and if you find it helpful, kindly mention in the comment section so that the others can also get benefited from your video. Okay, so thanks for watching. We'll meet again in the next video, where we'll be covering the exercise questions, that is 3.1 questions, and we'll continue our chapters. So as I mentioned in the previous video as well, if you are interested for one-to-one session, like an online tuition, you can mention your details to my mail ID, which is powerclasses.snb@gmail.com, with your phone number, so that I will call you back and we can discuss. If it is feasible to continue, or else it's up to you guys. Okay, but if you want one-on-one online tuition, because I know that there are few students which require personal attention, like one to one, they will feel it much better. Even for doubts also, it will be easy to clarify them. But if you feel that your children or your fellow friends require one to one special attention or one to one classes, you can just drop your details to this mail ID. I will check my mail and call you back, and based upon it we will discuss further. Okay, so thanks for watching. We'll meet again with the second video of this chapter, which is exercise 3.1. We'll cover few questions in their part 2. Thanks for watching, and please subscribe and enable notifications so that you will get notification for the live videos, because in the live videos mostly I are covering few homework questions which I will not be covering in the video section. Okay, thank you.